Today we will talk about converting circles between polar and rectangular coordinates. The first circle, x squared plus y minus 2 squared equals 4, is just a circle centered at 0, 2 with a radius of 2. And that's something that we learned a very long time ago in geometry, probably even before that. We did do it in Algebra 2 as well last year. So remember, the formula is x squared plus y squared equals r squared. And then if we have some sort of shifting of the center, then we will move the center a little bit. Now, in order to convert it to polar, what we want to do is replace x with r cosine and y with r sine. And so then the rest of this just becomes algebra. So r cosine theta squared is r squared cosine squared theta. And then we have to use the distributive property for r sine theta minus 2 squared. We get r squared sine squared minus 4r sine theta plus 4. And that equals 4. And then the rest of this just becomes a bunch of algebraic manipulation. So we get r squared, then we factor out the cosine squared plus sine squared, which equals 1. So then r squared times 1 minus 4r sine theta equals 0 because we subtract the 4 over to both sides. Then we can add the 4r sine theta over to the right, and we divide by r, and we get r equals 4 sine theta. The reason we're allowed to divide by r in this problem is because r is not going to equal 0 on the circle, so we're not dividing by 0. And then we end up with the exact same circle that we had in rectangular coordinates. So we'll see another example of this. So we have the x minus h squared plus y minus k squared equals r squared, where the center is at hk, so the center is at negative 3, 0, and the radius is the square root of 9, which is 3. This is something that we are hopefully used to by now, doing circles for several years. Now, in order to convert it to polar form, we're going to replace x with r cosine theta and y with r sine theta. Then we'll use the distributive property on the r cosine theta plus 3 because it's squared. We will get r squared cosine squared theta plus 6 r cosine theta plus 9. And then we have plus r squared sine squared, and that equals 9. And then when we do some manipulation, we subtract 9 from both sides. We factor out the cosine squared plus sine squared. We end up with r squared cosine squared plus sine squared plus 6 r cosine theta equals 0. We can subtract the 6 r cosine theta over to the right. And remember that cosine squared plus sine squared equals 1. Then we divide by r because r will not be 0 in this problem, and we end up with r equals negative 6 cosine theta. So negative 6 cosine theta is going to be graphed in the exact same spot on the polar grid that we had on the rectangular grid. The third problem I'm not going to do in depth, but you can see that it would be centered at 4, 0. And the polar equation, hopefully we're starting to figure out what the pattern is if we complete the square and stuff. We would end up with r equals 8 cosine theta. And my narration is a little bit ahead of my writing since I didn't have a microphone when I was writing it. R equals 8 cosine theta is my polar equation, and it would end up looking the same on the polar grid as it did on the rectangular grid. Except it's going to run off our page. So then, how do we describe the relationships between these things? What we will notice is that we have three different major types of circles that we are talking about in polar form. The first one is r equals a, which would represent a circle centered at the origin with a radius of a and a diameter of 2a, and that's symmetric to both axes. Then you have polar circles that we focused on the front of this worksheet of the form r equals a sine theta and r equals a cosine theta. R equals a sine theta is symmetric to the y-axis, or the line x equals 0, with diameter a and center at 0 comma a over 2. Polar circles of the form r equals a cosine theta are centered at a over 2 comma 0 with diameter a and symmetric to the x-axis, or the line y equals 0. Let's talk about a couple examples. If we know that r equals 3, we know that r squared is going to equal 9, and we know that r squared is x squared plus y squared. So that means that x squared plus y squared equals 9 is the equation of this in rectangular, and we're going to graph that right here. R equals -6 cosine theta. We already saw something that looks like this on the front, so we should be aware that this is going to be a circle that's centered at -3, 0. So we should know that it's going to be x plus 3 squared plus y squared equals 9. But let's do a little bit of algebra to prove it. R squared equals -6 r cosine theta, multiplying both sides by r. Then we replace r squared with x squared plus y squared, and r cosine theta with x. Then we add the 6x over and complete the square, and we end up with exactly what we thought it would be. So then we have to graph it. Like that. And the other two I'm going to do without narration, so hopefully you can follow along. Just be aware that this is the diameter that you see multiplied in front. So A represents the diameter, and the negative means that it goes on the left.